Alright, one thing that you need to understand is that in chemistry, mostly everything we do is about, it's more like we are measuring those things, because whatever step we take, it's about reactions. So you always actually, you are expected to measure what has been happening during the reaction, to observe at the end, quantify, which is the measurement. So you remember last time we looked at what did you look at last time?
Matter, states of matter,
Okay, one important thing that
properties of
I
matter.
emphasized was the properties, like such as extensive and intensive. Extensive, we said this one would depends on the matter available. So extensive depended on the amount of matter available. You remember?
Mm.
Example,
Yes.
example, you can talk of the mass. You say maybe 20 kg. The temperature will be something else. You can also talk about, let's say, the volume. You say, okay, I've measured the volume as let's say 30 meter cubed. Okay, those things. Then when we talk about intensive, okay, intensive, something that is
Mm.
intense. Intense is about something inside. So intensive, we can talk of things like temperature, things that are just constant when you mention them. Let's say the color. You won't say, okay, blue is 20 kg. You can't say that. The moment you say blue, that is just an intensive property. Also the temperature, let's say the temperature of a human being, you say it's 27 degrees Celsius. Let's say the temperature of the temperature of, let's say, not really the temperature of a room, like room temperature should be 25 degrees Celsius. You can talk of the density.
Yes.
Density, you can talk of, let's say, density of water is always 1 grams per centimeter cubed. Wherever you go, density of water, it has been like that.
Mm.
Is that okay?
Yes.
So if I'm to ask you, what instrument is used to measure time?
A watch.
Which watch?
A watch.
What about what instrument is used to
A
measure?
stopwatch.
What about what instrument is used to measure length?
Length. Same. Can you say a tape or a ruler?
Um, okay, yes, a tape. Good. Then what about what instrument is used to measure temperature?
Thermometer.
Okay, what instrument is used to measure mass?
Mass. Beam balance. Okay, speed.
Okay, we can use this one. You can use beam balance, yes. We can also use the electronic balance. What about the instrument used to measure volume?
Uh, volume. Volume, I'm not sure.
Okay, volume you use, like you can use even a bullet. All right.
Mm.
Yes, like a bullet, we can use a bullet, we can use other things like is it measuring cylinder?
Yeah.
Sure. So those things, so we'll be able actually to tackle all those things. Okay, so let me now
Mm.
go into details so that we focus. I was just trying to remind you.
Yeah.
Okay, so we can start. What we need to know in chemistry is that measurement will be a process of determining the magnitude of something and a quantity. For example, whatever you measure, you give a magnitude, let's say 2 meters. Okay, so this meter is the unit. Okay, then this value is the magnitude. Is that okay?
Yes.
So in chemistry, measurements are important because they
Let me
are.
write.
Sorry,
Should I write?
I don't know how you understand things, but I'm teaching you.
Okay, continue.
Okay, so what you need to know is that in chemistry, measurements are important because they allow us as scientists to obtain accurate, reliable results and also reproducible results, like results that will keep on reproducing themselves because we are accurate in the way we are doing them. And I'll come to explain what is accuracy, what is precision, so I'll be able to explain all those. So like I said, in chemistry we rely on measurement. Okay, so one important thing that we need to understand is the numerical number. So what is this, a numerical number? So a numerical number is, or a numerical value, by the way, pardon my handwriting is very pathetic. Okay, a numerical value is the number obtained from the measurement, like I explained. Like let's say you have, let's say, 2 kg. Okay, the kg are the SI unit, then this one is a numerical value. Is that okay? Then the other part is what we
Yes. So
call a unit. Like we have a unit there, anything should be in company with the unit. So
okay.
always this unit should be the SI or standard international accepted the units, or the units that the world came in order to actually standardize things. Like the case of mass, some mass, like in France, it was measured in quarts. So as a result, there was that total confusion in the global market. How should we, in as much as we do global exchange, how do we handle now the difference of these units? That's how they came up to say, okay, we'll have a meeting. They held a meeting in France. So that's where now they had to start, like, sit and also explain the what exactly units should we give, let's say, for time, because time can be measured in hours, minutes and seconds. So they came to a conclusion of a second. Just like mass, we can have in grams, but they came to a conclusion of kgs. You get those stuffs? Sure. So if I give you to say, can you tell me in 25 centimeter, okay, which one is the okay, so this centimeter is the unit and this is the value or numerical value. Is that okay?
Yes.
All right. So one important thing of these measurements, if we are to follow them properly, you'll find that they'll give us some knowledge on the following, such as we'll be able, if the results are accurate and reliable, we'll be able to produce will be accurate in our experiments. Okay, so one important thing of this measurement as a topic is that it will be accurate, so it brings about accuracy. So if we are see, if you are measuring the density, you need to present your density in what, in kgs, I mean in grams per centimeter cubed or kg per meter cubed, because you studied this topic as measurement, so you'll be accurate in the units part. We don't care of your numerical value, but in the units part you'll be accurate there. Okay, is that okay?
Yes.
So
Yes.
yes, the other thing is reproducibility. So what do I mean when I say reproducibility? I mean, like, so these are the important of measurement as a topic. So when you say reproducibility, this simply means, like, the result that you measure today, if you have been following all the procedure right and correct, you find that they'll keep on coming the same. Let's say 2.1, the other experiment, let's say 2.0, the other experiment again 2.1, the other experiment again, let's say 2.0. You see, so this is what we call reproducibility. Like the result, they keep on reproducing themselves because you are accurate. But if you are not accurate, you find that they will vary. Let's say the other point you have 2.9, the other point you have 3.1. How can you trace a pattern? You are not accurate when the results are coming like this.
Yes.
So that is one of the important of measurement in chemistry. Okay, so the other, we need to appreciate this. The other thing that we actually find is we'll be able to quantitate the result, because if the result are accurate like this result, I can find the mean. That is one of the way of quantifying like the result. I can find also, let's say, the standard deviation. You remember those in maths?
Yes.
So it's also about quantitative analysis. When you say quantitative, is the data that is given in numbers. Qualitative is the data that is given in like words, such as, let's say, yes, the color of something. That is qualitative data. But if I tell you to say your height is 6.1, that is quantitative form of giving the information. So quantitative analysis will also be given as a result of the importance of this topic. Okay, so we'll be able to quantify and analyze data. Is that okay? So the other thing that we'll find as a value of this topic is that we have the insight of scientific communication. So communication will be very easy because we all know the units to put under each physical quantity. Is that okay?
Yes.
So these are the important
Communication.
these are the importance of actually studying measurement as a topic in chemistry. So it's very important. You have seen the importance, right?
Yes.
Yes. So you may not appreciate it, but these are just the information that you get, and you can't even realize yourself that you have appreciated or you have applied the basic, the knowledge that you studied under measurement. When you start doing this, you will just be doing, but the importance is those we have classified. So example of things like quantification, let's say we perform a reaction, all those. So now let's go to about physical quantity. What is the physical quantity? I'm waiting. You learned this in grade 12. What is a physical quantity? Say
Reminds me.
so in short, a physical quantity is a quantity that can be measured. That's all. Is that okay?
That's all.
Yes, you can say it's a physical quantity is a quantity that can be measured. That's all.
Okay.
Yes, example of this physical quantity, we can talk of length. We can also talk of mass. In fact, let me give them like as anyway, that is the physics part for you to learn that these are base quantity or basic quantity, fundamental quantity. Those ones you learn them in physics with your lecture, but for me, I'm just interested in the part of chemistry. So then the other thing is time. There are 7 of them. The fundamental quantities are the one I'll list. Then the other thing is temperature, if I'm not mistaken. You remember these? There are 7 of them.
Yes.
The other one was the amount of a substance. What is the amount of a substance?
Uh, like Like in terms of what?
What is the other term we can use to refer the amount of a substance?
A mole?
Is there something like a phone ringing there or what?
Mm.
You can, it's disturbing him. You can know how to handle it.
Okay.
Okay, so the other one is electric charge. You remember this?
Yes.
So electric charge, or electric current to say, current, or just current, some people they call it current just. So this one, you look at it in physics like under electricity. So the other thing that we talk about is light intensity or luminous intensity. Is that okay? So now my interest
Yes.
is you to know the SI unit, the system international of units. So for length, just know that length will always be measured in meters, abbreviated by small letter m. Then what about mass? What is the SI unit for mass?
Kg.
So this is the kg.
Kilogram.
Okay, what about the SI unit for time?
Seconds.
What about the SI unit for temperature?
Temperature.
Yes.
Degrees.
Wala boy.
Degrees Celsius.
Wala. The standard is always
Is that?
Kelvin. Kelvin. You see how we convert. It's Kelvin, okay?
Oh, Kelvin. Yeah.
Okay, ama degrees here nuko hospital. So the other one, amount of a substance, this is a mole, and we measure a mole just removing the E.
Mm-hmm.
Okay, so then for electric charge or current, we measure this using amperes or A sometimes. Let's say 20 amps. You see these on the electrical appliances, they are actually indicated like this. So then
Big
light,
letter A.
yes, light intensity, that will be a candela. So a candela will be just represented by CD like that in small letters. Okay,
Yes.
sure. So one thing that we also you need to understand is that the other things that we measure also, we need to know their units, like volume. The standard unit for volume, since this is not a basic quantity, like it's not among these 7 fundamental, but I have to include it because it's very important in this topic. Like volume, volume should always be measured in liters. This liter is also equal to decimeter cubed. Okay,
Mm-hmm.
then I
So
can,
it's like volume.
like the volumes, they are derived quantity. This you learn in physics. Ask your lecturer to say what is a derived quantity, what is a basic quantity, you explain. So when you say these ones, they are basic fundamental quantity. Is that okay?
Mm-hmm.
Yes, you even choose these 3 to start under dimension analysis. You see how what I'm talking about. Like for now it is not making sense, I know, but you appreciate it later. Okay, so that is it. So density should be measured. Yes, when you have kg as your mass, then expect your volume to be in meters cubed. Then when you have grams as the mass, then expect volume to be in centimeter cubed. Is that okay?
Yes.
That's how you should do. So when you're asked to calculate density and one of the units is not matching, try to change it so that it can match with the volume, or change the volume so that it can match with the mass. Okay.
Okay.
Sure, the concentration also is one of the things that I need to talk about. When you say concentration, it's just the amount of solute in a given volume, right? So concentration will be given amount of something which is a mole, then over volume. Okay, this is the standard concentration that we have been, and it will have the unit m as the unit of that. You remember this under stoichiometry.
Yes.
Okay, so now let's now understand what we call matrix prefixes, or just prefixes. You tell me when you are tired. This is just the knowledge, basic knowledge I'm giving, so that you are able to overcome those big ones that will be coming in form of a question. If you are able to come up with this data of slow information, then you'll be able to handle any challenge. Yes. So let's go. So I said we'll now understand what we call prefixes. Alright. So let me write that. My handwriting, why is it bad like this? Kwatia kwa mapalo.
My handwriting is nice.
Kaleteni fyama avocados naimwe. Takole tapale fyo mulelanda. Alright, so okay, so what do we understand when you say prefixes? So prefix, what do you understand by this? I think you learned this.
Grade 10.
Okay, in short, these prefixes will be used because as much as we are studying this this chemistry, we will find data, let's say on our calculator, let's say given as 6 point, let's say 022 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0, a lot of zeros like that. So now hence the coming of prefixes, whereby we understand this big number in just in a simple way. Okay, so this 6 point something, it can be written as 6.02 times 10 to the power, let's say there are 23 zeros. So you'll see, so this is how we communicate as scientists. So we'll be writing in this form as prefixes. So this number 23, it is a prefix. This 10 to the power 23. So 10 to the power 23 is a prefix that helps us to understand large number. This one is not an issue. Okay, this is where we count the number of significant figures from there. Is that okay?
Yes.
So I said this part I circled, this is where we find the number of significant figure expressed in that form. Significant figures, is that okay?
Yes.
Okay, so whenever you see this number written, let's say I ask you how many significant figures, there should be 3. In short, numbers that are like here within this boundary will be able to communicate also the significant figures. Then this part is what we call the prefix, which has helped us to reduce that big number, especially the zero confusions. So that is the prefixes. They are helping us to understand very small number and very big numbers. Okay, suppose I have something like 0.000000000, let's say 21. You see, I will say, okay, I'll move from the negative. I'll say 1 2 3 4 5 6 7 8 9 10. So this can be written as 2.1 times 10 to the power negative 10 again. You have seen? Because I'm from the negatives. I'm from the negatives if I'm to start here. let's say this is a Cartesian, here they are negative, here they are positive. So I'm starting counting from negative going there, so I will still carry a negative. Is that okay?
Yes.
So that's how we give a negative or a positive. So if I'm like this, yeah, in that manner. Okay, let us now understand these now in details. So the most common prefixes that will be given are the following. The first one is kilo. Okay, the second one is when you say kilo, it has a factor of 10 to the power negative 3. Is that okay? So for example, if I write, let's say what
-3.
positive 3, a kilo. Let's say I write 1 kilometer. This simply means that this kilo we know is 10 to the power 3, which is just 1000. So I'll write like that, 1000 meters. You have seen? Because this 1000 is the value of
Yes.
10 to the power 3.
3.
Sure. So again, the other prefix that I want you to understand is the cent. You have been hearing centimeter, centani. So this cent, I'll just write like that. Then it is 10 to the power negative 2. Okay. So if I like to say, let's say I give you 1 centimeter. This is same as how many meters? You say where there is cent, you put 10 to the power negative 2 meters, because the cent has been replaced by 10 to the power negative 2 there. So this means that we can write this as 0.01, right? Meters. So that is the relationship you get to centimeter with meters. Okay? Yes. So this means that I can also bring it like this. See, I have 1 centimeter as my relationship, which is equal to this 10 to the power negative 2. It's more like 1 over 10. Is that okay? To the power 2, like that. You have seen? Meters.
Yes, inverse.
Yes, good. You're even able to remember inverse. Okay, then we can write this as 1 centimeter again is equal to 1 over 100 meters. Okay, so if I'm to cross multiply here, I'll have 100 centimeter is equal to 1 meter. Have you seen?
Yeah.
You have seen the relationship, right? So you find that that meter rule they use to write things on the board in class, that yellow meter rule in your school, that is 1 meters. It is 100 centimeter, but it's 1 meter. Okay. So the other prefix that I want you to understand is what you call a milli. So it's you abbreviated with a small letter, then it has the value of 10 to the power negative 3. Okay. So
Yes.
if yes, milli. So if I say 1, let's say millimeter, how many? You can even say how many, like you can even get a relationship, because you know the millimeter, the milli is there. We have 2 millis there. So you can get 1 meter and say, okay, that will be 10 to the power negative 3 meters. And that's a relationship. Hence we can write 1 millimeters is equal to 0.01 meters. So that is the relationship there. You have seen? So by this, if you can understand the kilo, the meter, the cent, the milli, you'll be able to convert any unit and find the relationship. Okay, so that is it, how I can appreciate that. Then the other one we can talk about is what we call the macro, the micro to say. So it is presented by this mu, the word is mu, so it's micro. So this micro has the factor 10 to the power, or the prefix 10 to the power negative 6. Is that okay? So if I bring something
Yes.
like, what is the relationship between, let's say, 1 mu or micrometers, how many meters will be there? So you say the meters that will be there will be 10 to the power negative 6 meters. Is that okay?
Yes.
Yes, so that is it. And the last one that I want to give you is um, um, nanometer. It's called nanometer. It's 10 to the power negative 9. Okay, there are other prefixes, but we'll talk about them as in details. Okay.
Mm.
Okay, I think let me just expand the knowledge so that we appreciate and forget the rest. So we have talked about the macro. Let me talk all of them so that we end there. Hi.
Yes.
You're fast in saying we end.
Eh. I woke up early.
Eddie doing what?
Ah, preparing for this same class.
Okay, good. So now let me bring those prefixes and you see how they will be used. Okay.
Mm.
So for example, I want again to remind you, you can even find a way of mastering them. Is that okay?
Yeah, I can find the way.
So the first prefix that I will start from the positive, then I go to the negatives now in that order. Okay.
Mm.
So there are lots, like, but there are those important ones. So when you talk about let me start with the positive ones. So the first positive that we have is what we call a deca. So a deca is
Mm.
when you find a number expressed just as 10 to the power, okay, or to the power 1. So that will be the factor associated with that deca. Is that okay?
Yes.
Then there is what we call a hecto, but these we don't normally use them. I'll tell you the sensitive one and you should I'll also apply them, like I'll give an example. So hecto, it will be 10 to the power 2. Okay, now the important one that you need to understand is what we call the kilo. So the kilo has a factor of 10 to the power 3. Clear?
Yes.
So like after I'm done with the positive, I'll give an example. So the other one that we can call again is what we call a mega. So a mega has, so say a mega. By the way, let me be lighting the symbols there. The mega, it has capital letter M. Then the kilo, it has capital letter K. Then the hecto, this is just a small letter H. And also for deca, this is just a small letter DA. So those are the symbols associated with that. Then when we say a mega, this is just a 10 to the power 6. Then we have also what we call a giga. I think I should end there. So a giga has a 10 to the power 9. I should end there with the positives, I think. Or maybe let me light the other one. We also bring something like Taylor. I think Taylor, something like which has to do with Taylor. It has to be 10 to the power 12. Okay, so now see how we can use. I can give you the answer to say, let's say 2.6 times 10 to the power let's say to the power to the power to the power 11, okay, grams. So they'll ask you to say write this in the nearest or closest prefixes or metric prefix. So what you do is you just move this point, okay. You know that the closest
Remove the point.
no, see, we have 2.6 there. So we have 2.6 and
Yeah.
the closest prefixes is 12. How should we handle this? It means that we have to take these ones there so that we increase the positive. You have seen? So that would be 10. If we were to write that, then that would be 26, okay? Are you there? I don't want you to get
Yes,
confused. So what we want to, how can we move this point in order to have to increase this value there to 12, because that's the only closest prefix there. And remember, this is a capital letter T. Okay, how can we increase that one? Like, we have 2.6 there. How do we move the point in order to have 12 there as a power? So you say this one, it has to go there so that the positive can increase. You have seen? We go like this, we're coming from positive, so we're increasing the positive. If I go like this, we're increasing the negative, like I demonstrated for the other one. So what you do is you have 0.26 times 10, okay, to the power 12 there, grams. So this 12 can be written as 10 to the power 12. We can replace to say this is 0.26. Wherever there was 10 to the power 12, we write this letter there. That is Tera. So you write T grams. So that's how you can express it in closest prefix.
Wait, repeat.
Ate repeat again. Right. So okay, so what I'm trying to say is they will ask you to say, let's say they give you, let's say 10 to the power, let's say 2.6, I'm just giving an example, times 10 to the power negative 8. Okay, so when you go from the negative to positive, from there you are increasing the negatives. Is that okay?
Yes.
So this we can write it as 26, then the 0 will come there, okay, 0.0 like that. You have seen? Since now we have moved 1, meaning that the 10, the 8 there will be negative 9. You have seen? Let's say this was meters, so write meters there as the other units. Then now we have now, remember the question is about express the following in the closest prefix. Okay, but this I can't tackle this.
Yes.
Let me just go back to the example because I haven't given you the negative, so I want to work on this. Let me continue the positive ones that I have. For example, they give you a number to say write the following in the closest prefix. Let's say we write 2.561 there, then times 10 to the power, let's say to the power 5. Okay, so for you to, you know that if they have, let's say, let me put, let's say as seconds, okay, as just the units given. So they ask you to say, can you write this in the closest prefixes that you know? They will ask you like that. So what you do is you only know that for positives the only closest prefix I have is 6 there, which is mega. So what I'm going to do, I'll move this point to this part so that from the positive to negative, so that I increase the positive. So what I'm going to do is I'll move there, that will be 0.2, you have seen, 5 6 times 10. Now since I've increased there, I've moved once, so the point there, it will increase by that. it will be 60 seconds. So you have seen that. Have you seen?
Mm.
Yes, we had second.
Yes.
We have second there. So meaning that we have 0.256. Where there was 10 to the power 6, we are replacing that, which is mega. So you write capital letter M like that. Seconds. So you have expressed in the closest prefix given that number, which was. Sometimes it will be direct. They will put, let's say, 12 there, or 6, or negative something. So you have them like in mind. But if they are not, they haven't put it direct, then you have to round off so that you go to the closest prefix there. Is that okay?
Yes.
Good. So are you tired? We do the
No.
negative. Let's
But
Okay, let's do the negatives
but
there. Me, I can't get tired. I'm a machine.
same.
Okay, we'll see the machine. Let's go until 16 hours. Alright.
Mm. Okay, let's continue.
Yes, so those are the positive prefix that will be asked. They might others like 10 to the power 15, but I don't want to express it here. You explore those as you start, but these are the most important ones, especially the kilo, the giga, and the tera. So let me also give for kilo. For example, I have a number to say 2 point, let's say 6, okay, then times 10 to the power 2 there, okay, then let's say meters again. So they will ask you to say write the following in the closest prefix. So what you can do is always, this one is already 10 to the power 2, and we have that in mind to say it's a hecto with a small letter h. So you just write that as 2.6 then h meters. Is that okay? Because you have in mind. But in a situation whereby let's say it was in a situation whereby let's say it was 2.56 then times 10 to the power, let's say 5. I mean 4. Let me write 4 there. 4. So the only way we can do this is to move the point to from negative to positive so that we decrease this one. In short, the only way we can write this, we can choose whether to lower it to 2 to the power 2 there, or to the power, what am I writing? I was supposed to write that, let me write like that, to the power 4, so that we see how we can adjust. I'll adjust it to kilo. So the only way I can do this, I'll say I'll move this point there so that to the negatives. Once I move like this, what am I doing this? I'm increasing the positives if I move like this. But if I move like this, I'm increasing the negatives. Is that okay?
Yes.
So if I increase the negative, meaning that I'm adding a negative, that's the increase. So that would be, if I let it to say 2.5, I mean, let me bring that point where it's supposed to be. So if I write like 5, the point comes there, then that since it has increased by negative, it will be now 3. You have seen?
Yeah.
Okay, so let's say again this was in meters. So this means that we have brought it to kilo, and we can now fit the kilo because we have expressed it in that manner. We have adjusted. So that will be a kilo like that, kilometers. If you want, punch this. Let's say we know this kilo is 10 to the power 3. 10. Punch it to say 25.6 times 10 to the power 3. What would be the answer?
I thought 25
Yes.
point.
0.6 times 10 to the power 3. Or times 1000 in short.
25.6 times 1000.
Okay, so you see it is giving you this, right?
Yes.
Times 1000, which is this sound. So you see that the communication is quite alright. with the kilo replacing the kilo there is quite alright. So hence this is how you express it. I think I'm done on the giga. Also you can also try for giga. The mega we have given an example. I think we have given an example. I don't know if you do a screenshot there or you watch the video later. So let me talk about now the negatives. Okay, so we talk about the negatives now. So also the negatives, I'll start from the smallest. So the smallest negative prefix that we have is what we call a des. So a des will be represented by the letter D. Okay, D. So this decimeter, I've been hearing about decimeter. So this des will have a factor of 10 to the power -1. Decimeter, decision, centimeter, decimeter. Okay, so then the other one that we have is what we call the centimeter. The cent, you have been hearing the cent with a cap with a C letter, so we say a cent. So this cent, it has 10 to the power -2. Like centimeters, this is what I was talking about. Like 1 centimeter is cost, 1000 centimeter is cost 2 meters. Like 100 centimeters cost 1 meters. You saw how we converted those things. In short, this the cent, the des, those are the like things I want you to be understanding. Like the cent, the des, what does it mean? So you can easily replace. Let's say I write 1 decimeter like that. Okay, like I have 1 decimeter there. Okay, you have seen? Let's say 1 decimeter. How many meters will be there? So the meters that will be there in 1 decimeter is, you replace that will be just 0.1 meters. You have seen? Because that is 10 to the power -1, which is the decimeter there. So that's how you can easily find the relationship, if you can know the communication of des, cent, meters, milli, wherever it will be. Okay, are you there? Alright, so I'll continue even if you are not there. Okay, so the other thing that we need to understand is what we call the milli now. Milli with a small letter m. So this will be milli like that. Okay, so then the milli will have 10 to the power -3. Then I'll come to give an example of each. Then the other one that I can give again is the macro. I think I gave the example, this one with the letter mu like that. So we say micro or micro. Yeah, it's micro. So this micro will have 10 to the power -6. So the other important prefix that you need to understand is what we call nano. So nano, it will have the n as a symbol. This nano, I think you know it is 10 to the power what is nano? Nano, it should be 10 to the power negative what?
-9.
Yes, like nonen. You remember how we were naming those compounds, like organic compounds? Nonen, octane, decane, all those things. Alright, so the other thing that we need to understand is what we call the pico. Alright, so the pico, it will be to the power 12. So I'll end at pico because I'm just comparing with the other guys which has 12 as well. So this is pico with the small letter p. So pico. These are the negatives, right? So I think it is now also reminding me to give you the other one, which is femto. They like femto. So femto, it has a small letter f. So femto like that. So this femto, it has 10 to the power negative 15. So to the power negative. You will see how we can use this femto. I've been saying in question papers, the case of CBU, they like femto, though it's very big, but they like it. Okay, so now I can give examples. Femto, yes. Femto, MTO. Femto. Femto.
Then for the micro, this is the katimbo. It's also an M.
No, micro, this is micro, like this. A U with those things there. A U with that. I think even on the calculator is there, this one. Okay. Alright, so now let us see how we can apply these. Like, remember, I've already shown you how they bring questions. Do you want this part to be still there?
Which part?
The positive ones.
No, no, you can have.
It will be very difficult for you to compare. Let me just see, so that you can be mastering from there. Like, what would the opposite of, let's say, kilo, what would the opposite of what, you'll be able to compare. Let me but give examples based on these ones, these negatives. For example, they will ask you, they will give you a number, let's say 0.261, okay, then times 10 to the power negative, let's say negative 4, no, negative 5, let's say, grams. Write this to the closest prefix. You know that if you are moving from negative to that, you are increasing this, you are adding a negative 1 to that power, okay? So if I know that this is given as negative 5, so the best way I can approach it is that negative 6, which is the micro. So I'll move this one to this point, hence I've increased them negatives. So I'll say 0. No, it is 0.2 point something like that. Okay, suppose this was a number here, this is 8, okay? Okay,
yes.
So this means that we can now bring it to the closest prefix which we have beside 5, because we don't have 4. Would have manipulated to 4, like to reach 4, this negative as negative 4, but we just add negative so that we come to this side, to the positive one, so that we can reach at 6. So that would be 82.61 times 10 to the power negative 6 now, because we have moved that point. Is that okay? So this means that wherever there is 6, we can replace what we call a micro. So we'll say 82.61 then times micro, okay, grams. So this can be written as 82.61, then we can write micro there, grams. You have seen how we can use this.
So whenever dealing with the negative, I always supposed to add the 1.
Like, you look at what you have in mind according to this, what I've given you, which one is closest. Let's say it was negative 5. So you moved from this to your right. In short, you are coming from negatives, meaning the negative is increasing. If you are coming from positive, the positive are increasing. It's the opposite.
Okay.
I want you just to master how we manipulate this negative in order to reach the desired or closest prefix that we know. or you see. So they can also like give us a question with the closest, let's say, to the negative 14, but you need to know how to manipulate in order to reach that point. For example, let me try for femto. So they will give, let's say, 2 point. I like using 2, I don't know why today. Let me change. You may think they always use 2. So let me let 3 6 point, let's say 1 2 times 10 to the power of negative 14. You have seen the only closest prefix we have there is 15. That's what we know. We don't have 13, so we would have manipulated to reach 13, but we don't have 13 as the closest prefix with us. So the best way we can do is we manipulate this. To increase this, we'll move, we'll add a negative there. We'll ensure to move like that one step, then it means you have added negative 1 to make 15. So that will be 36 from pick. Blind, you from pick? Pick, I can see my guy. Okay, so that is 36. Then the point will come there where there was 1 2, then times 10 to the power now negative 15. We have manipulated this, you have seen. So we can now replace. We know what is the factor for 10 to the power 15, so that would be 36 1.2. Then wherever there is that factor, let's say this was grams, wherever there was that factor, we'll replace now the femto, which is just F grams. Clear?
Yes.
So that's how you can use.
All of them are in grams.
No, I was just putting. They can put any units, Kaide. They can put any units. Like if I put S, it will look like 5. That's why I don't try. They'll put even meters. Okay.
Okay.
Yes. I'll show you the question paper I'll send. Okay, so those are the things to know under prefixes. That's how we use them. You can also, like, let's say I write something, let's say 2 point or 1 2 point, let's say 3 1. Write this to the closest prefix. Let's say I write, let's say, meters. So the only way you can do this, you can manipulate by taking this one and say, okay, since I've taken like that, I've moved how many times? I've added a negative there. Okay, is that okay? So this means that if I've added a negative, it will be 2 point, it will be 1 point, I mean 1, which is 12 31.1 meters. I mean, since we have made that moving, we'll multiply times 10 to the power negative 1, because we have moved to the from there to the negative like that. Is that okay?
Yes.
Okay, let me do this. I need to end this soon. Okay, let me just solve this, then we end it. I don't want it to reach 1 hour. So that can be written as 3.1 meters, but we have moved 1, so we have put 10 to the power negative 1 meters. So this means that we can now replace there. We can say 123, okay, 0.1. Then the 10 to the power negative 1, we know it's des, so just like d meters there. Is that okay? I think this marks the end. I'll send the questions so that I don't want this video to reach at it's almost.
Okay.
Yes, I think this marks the end. Let me send the video. Bye. Have a good day.
Bye.